We now consider molecules that are more complex than the simple single center polyatomics that we looked at in the last video. These are something I'll call larger molecular structures, and there's a whole great variety of them, so we're really only going to scratch the surface with this. Our learning goals are to look at some of the primary building blocks that help us build up more complex molecules that have several connected centers. So multiple center molecules, what does that mean? Well, any atom with a bonding capacity that exceeds 1 could be a central atom, and we can see some examples of that already. If we have more than one of these atoms, so if we have 2 of them, for example, and they're connected together, then one can build more complex structures. So that's what we mean when we're talking about multiple center molecules, molecules that have more than one atom that can support multiple bonds. Let's look at ethane as an example. Here's a picture of the Lewis structure for ethane, and you can see that with the 2 carbons connected to each other, they represent a 2-center molecule as opposed to the single-center molecules we looked at before. Now, of the elements that we will be considering primarily in this course, we're going to focus on carbon, nitrogen, and oxygen because they can support these large molecular structures, particularly carbon and nitrogen. Because carbon is the primary one with 4 bonds, a bonding capacity of 4, we're going to refer to these molecules as carbon framework molecules because we'll find that most of them have, if you will, an infrastructure that is built around carbon atoms, occasionally with a carbon atom that's replaced by a nitrogen or an oxygen. Now these are the fundamental building blocks that we're going to see, and I want to spend a minute or so on this chart so that you can understand what's going on here. We're listing carbon, nitrogen, and oxygen with their bonding capacity. Carbon has 4, nitrogen 3, oxygen 2, and these are the possible structures that you might find carbon embedded in the center of a complex molecule. Now you'll notice that all of these represent variations where carbon has 4 bonds and it has no non-bonding pairs of electrons. Carbon typically does not have a non-bonding pair of electrons in any of its stable molecular structures. Now I'm going to refer to the one with carbon with 4 single bonds, 4 sigma bonds around it, as a primary structure, whereas all of these varieties where carbon is engaged in a multiple bond as secondary structures. Now nitrogen has the possibility of 3 bonds with 1 non-bonding pair of electrons. Now again, we'll call the one with 3 sigma bonds, 3 single bonds, as a primary structure for nitrogen, with these other variations that have multiple bonds as secondary structures. Finally, with oxygen, we have 2 bonds and 2 non-bonding pairs of electrons around it. And there are really only 2 varieties that we typically find oxygen in these carbon framework molecules. Our procedure for building large molecules, and I use this hesitantly because we don't really build up large molecules this way in the same way that we do single center molecules, but let's go through the procedure anyway. We're going to connect atoms that have a bonding capacity greater than 1 first. In other words, they're going to form the framework, and all the atoms that have a single bond, like a hydrogen or a halogen, they're going to be on the outside. They're going to be on the periphery of the molecule because they can't connect you from one atom to another. There may be multiple ways to do this, and this is why this doesn't really fall in the same category as the single center molecules, because really all we're doing in this case is we're trying to look at the possible structures, and there often are more than one way to do it. After we've connected those central atoms, we'll add the terminal atoms, those that have only a bonding capacity of 1. We'll refer to them generally as terminal atoms because once you've attached them, the chain or the size of the structure goes no farther. If there are unused bond connectors at the end, then we can create multiple bonds. Sometimes we have to conspire to make those unused bond connectors be on neighboring atoms in order to make the multiple bonds. These building blocks are really a way to understand structures. They really are limited in their ability to predict a structure from formulas, particularly when there are multiple different ways to do this. So I want to be clear that this is not like Lewis structures for single center molecules. This is really just a way to test the possibilities. So let's look at an example, propene, which has got the formula C3H6. Now it's pretty obvious that the 3 carbons are the ones that are the multiple bonded atoms in this, so they're going to be the ones that are connected together. So here's a simple structure where we connect the 3 carbon atoms together. Right now, We can add the 6 H atoms. These are all terminal atoms, but there are 8 vacancies on this infrastructure that involves 3 carbons, 1 on either end and 3 above and 3 below. So we're not going to be able to fill up all those bonds. As a result, we're going to put the H atoms on here in such a way that we leave 2 of the carbons with an empty, dangling, non-used bond connector so that we can make a multiple bond out of it. So when we do this, we end up with a picture, for example, that looks something like this. All right, now we'll create a multiple bond, a double bond, using the 2 connectors that are not bonded to something else. So they both come down and can form that double bond, and we end up with a molecule that looks like this. This is in fact the Lewis structure for propene, but this example was chosen because there's really only one way to put these atoms together. Actually, there's more than one way to do this, but there's only one way that follows the rules that we've done so far. So now I'd like to invite you to use building blocks to construct a molecule that has formula C2H6S. And be careful, you want to identify all the atoms that can make more than one bond and make sure they're connected together, and then add the terminal atoms at the end. I'll give you a chance to do this first, and then we'll go through and talk about it. So you may pause the video now. Okay, I hope you've had a chance to work on this. Let's go through and look at the different parts of this. First of all, we've got these primary building blocks. We've got 2 carbons that each form 4 bonds, and sulfur that forms 2 bonds. It's kind of analogous to oxygen in that way. And then we've got 6 terminal atoms, which are all the hydrogens. So if we connect them together, there's actually 2 ways to do this. So in this case, we're going to end up having this or this. You notice that in one case we've got the 2 carbons connected to each other, and then one of them is connected to the sulfur. In the other one, the sulfur is in between 2 of the carbons. All right, so this is something we never run into in single center molecules, but this is telling us something new about these complex molecules, and it's actually something that's fairly interesting about them, and that's something we're going to follow up on in one of our subsequent videos.